before you do your study and go and say that's this kind of sediment, maybe take a look at what the sediment things are, and then you can give a grain size or something that would actually make the data more useful and follow the categories, or know what your benthic components are in the model. For example, coral reef, you might just say, if you go and you want to say it's reef biota, you might go to the level, it says shallow mesophotic coral reef. I'm not in a Trondheim, Norway cold reef, but people often say, you know, coral reefs, and they don't think cold corals. So in this case, it's a shallow mesophotic reef. And then these are the biotic groups, and now there might be bunches of different ones, but if you know you're looking at a plate coral, then make sure you say that, and if you knew the species or the community. So it's good to take a look if you're doing that kind of work ahead of time, because it's always hard to go back and make your categories after you've done your field work. So take a look. You know, if you're doing calcareous algal beds, you know, you kind of know what the different categories are, because now when you submit it to sea bass, you'll have to tell them which category it is, and as far as you can go in the spreadsheet. So even down to, I was in gravel boulders. So we talked about the beautiful boulder beaches of Villefranche. Who was in the course in Villefranche? Oh yeah, hi. So you remember those gravel beaches, right? So it was lovely. But just keep in mind these are categories, and as it do the best you can, or how to do these things maybe aren't so simple, but it's good because then we can start really parsing out spectra for different things, and being specific, not just this is sediment. Well, great, but did it have a biofilm? And I wanted to show one of Stacy's beautiful, this is her photo mosaic project. So this is not just one picture. This is how many images?
It depends on the site, but probably close to 1,000.
1,000 that she's photo mosaicked into this beautiful coral reef. You can see there's a little bar for scale here. So she and a blue one up there for image quality. But you know, so we're starting to look at these scales of things and how you would categorize. This isn't so simple, right? There's a lot of different types of corals, mixtures, sediment, sand. So this is one of the future areas, right, is just how do we represent healthy corals, bleached corals, communities, and be advised, if you're trying to get down to a meter scale here, it's very hard to validate a meter scale, and partly because it's not where the image says it is, also because of the index of refraction changes. So there's a whole bunch of stuff with working in these areas that it's great. It's a whole opportunity, and there is this big data set. We've been now to Guam, Palau, Australia, Hawaii, and Florida. Did I miss one?
Florida didn't work, so.
No, Florida, there was a big storm, so sadly they flew it, and then we ended up getting there. They flew it on opportunity, and then everything was just turbid. So really nice turbid water spectra. So, but not very optically shallow when we got there. So anyhow, so there is a lot of data. It's going into sea bass, and you can play with it too. You know, there's a whole wealth of stuff out there that are pushing the boundaries. So this was flown with an aircraft called Prism at 10 meters. So how big are these bars? Like
Half a meter.
Half a meter. So this, in this case, will be all in 1 pixel. So you can imagine how that would look and how to categorize 1 pixel of bright sand with some coral. And so you can just suck this into hydrolite, right, Kurt, as your bottom? No, I'm just kidding. That's the future.
Yeah, well, that looks a little bit 3D to me there. But, you know, if you have this however many meters pixel, and, you know, hydrolite's going to see that as like a smeared out average bottom reflector.
A flat bottom.
Yes.
So yeah, so we can simplify it. This is how hydrolite would currently sort of do it, just coral, algae, sand, and that's where we're at present. But we're also working on this, one of my student, Brandon, who also took this class, looking at how corals respond different, the same corals but with different symbionts. So nobody's actually, a lot of the color is from the zooxanthellae, and you might just go down and say, I know this is a certain species, Cerealia, or Cyphostrea cerealia, but then there were two different symbionts, one that was temperature tolerant and one that wasn't, and we didn't find a difference, but it was the first study that actually said, well, is there a difference in symbionts? Can we get to the level of temperature tolerant ones to ones that are not, or more generalists to more specifics? But you can see another little delightful fluorescence peak. These are green fluorescent proteins, and sometimes corals have that. So this is another little blip to be aware of in your future analysis. So, and then we've done a lot of imaging now, working up that data on the three-dimensionality of coral heads and where, this is just a simple chlorophyll algorithm, but you can see they have chlorophyll inside the channels more than outside the channels. So maybe we won't use this for remote sensing, but if someone's doing reef health, they might want to run an imager along the bottom and be able to say how much pigment there is, how healthy are they, you know, ultimately to maybe space-based applications. And looking at three-dimensionality with John Headley, for our history project, we're giving him a lot of three-dimensional data. I was making molds of corals because I was like, I really want to know the shape. So I went to the pottery store in Hawaii, or the art store, and I got a bunch of like pottery, and I made molds, and now we're scanning those. So, you know, you never know. I was like, I really want to know what the reflectance does at different angles. So we have this whole database, and I have a student starting to look at that in the fall. So, yeah. So this is John's thing. So I'm just going to leave you there with some exciting, one final. Okay, a couple final things. I love doing ecology. So, you know, we're working on some papers. This one's not mine. I just thought this was interesting. How can dragonflies discern bright and dark waters from a distance? The degree of polarization of reflected light is a cue. You know, we can take our stuff, and I've been working on a heron project, how herons forage, and that's been submitted recently at the air-sea interface to avoid glint and see into the water. So that one's being submitted, and it was just, we did a lot of hydrolite runs of glint and the sea surface and different winds, and looked at herons and the angles. So you can actually take your studies into other directions. This is one we just finished. Camouflage and polarized environments. Recently was in Science, so it's kind of a big deal. And we looked at how silvery fish camouflage in an open ocean with my colleague, Molly Cummings. And we did a whole bunch of experiments with polarized, a polarimeter and fish and mirrors of different reflectance, and measured how they actually reflect light better than a mirror. So to the polarized eye, they're doing it physiologically, and then we looked at Molly looked at the platelets and the way they arranged their skin to do this, and now it's turned into a project where they're making metamaterials that can reflect better than mirrors based on what the fish skin is. So you never know, like you might be working on cool things like this that, you know, is not directly a satellite but has applications to a wider sense of evolution to applied materials. And finally, I just like this sensor that this EPIC was canceled recently, but it's out there collecting data. It's getting a full sunlight disk of the Earth every hour. It has 10-kilometer pixels, which is shocking because it is 1.5 million kilometers from Earth. It has a giant telescope. It has 10 narrow bands, which include MODIS. The blue's at 10 kilometer, the MODIS other bands are at 18, and it sees every hour the full sunlight disk of Earth, and nobody's using this. Like, they're looking for science team. I'm guessing they're going to ask for proposals. Brian said he thought maybe they'll provide it on, I'm not sure, I don't want to paraphrase, but he was maybe toying with writing a proposal to do some ocean atmospheric correction. But how cool is this? We've never looked at the full disk of Earth, and that, by the way, was not Martians, but that is the dark side of the moon. So you saw it here first. So there are cool sensors we didn't put up for ocean color that are doing some cool things, and maybe we should be also looking at, I mean, as the Earth, look at what the clouds do, the ocean surface. Are there applications every hour to look at the full Earth at 10 to 18 kilometers, depending on how far? Obviously, the pixels are bigger, a lot bigger on the edge here. But it's still kind of cool. So I'm just saying that keep your brain open. There's cool things up there. You guys could be thinking of new science questions that we haven't even thought of yet. All right, so with that, I will leave you. I'm not sure what exactly I gave to the... All right, so any questions? It was a pleasure chatting. All right, well, let's take a little break, stretch your legs.
No, we're going to take an half an hour break.
Oh, you have some snacks.
Wow. So good.
Should we take them after coffee?
Yes, I take some after coffee, so I won't
We
ruin
have
the
them after.
surprise.